Okay, so the use of normalization first. Why are we studying normal forms, right? What is the use? We were fine, we were creating tables, we had databases, tables, we were doing queries on it, and we were getting a data. But it's not that simple, right? Life is not that simple. You don't only have one table in a database and that's all about it. Think about college itself, Georgian college itself. If you were given the task of creating a database for it, the first thing you would think is, oh, there are students in the college, there are teachers in the college, there is non-teaching staff, then there are suppliers to the various services in the college. I can put all their data together in one table. You can do it. Like, it's not logical, right? So you start thinking of what are the entities about which I want to save information. And then you think about what information do I need to save about these entities. So definitely you will have more than one tables, and these tables will be related. For example, if a student is taking some courses and I want to find out who are the instructors of these students, then definitely I'll have to find out the courses they are taking, then the teachers who are teaching that course, and then relate and say, oh, these are the instructors for this student, right? So there have to be relationships when you create tables in a database. So now, what is normalization? Normalization is the process by which you create tables in such a form that the tables are perfect in design. When I say perfect in design, there are a few rules to be followed. What will perfectness in design give you? Select statements will be complicated, but the select statements, they will help you to kind of create these right select statements. So you will see that there will be no redundant data, there will be no replication of data. Insertion, deletion, and updation of records will be easy, right? If you don't think about these concepts, normalization, as you go on, your job will be very difficult. Every time you will have to update a record, you will see, oh, maybe there will be inconsistency of data or data integrity will be lost. And we'll just talk about it. So we'll go step by step. So these normal forms were created. They're just rules. They were created keeping in mind how to create a good design, how to create well-designed tables in a database. And these well-designed tables lead to non-redundancy of data. Data is not duplicated. Data is always the correct form, right? Even if you have to keep duplicate data for whatever reasons, you will take care that at all times data integrity is maintained. That is, data is the same in all the tables. So these were kind of rules which were created, that when you create your tables, be careful of these rules, because if you are not, then down the line, definitely you're going to have problems with select statements, update, delete, and so on, right? Those are the things you do. You either update records, you delete records, or you select records. So all these will create problems. So keeping that in point, these normal forms were created. They are first normal form, second, third, fourth, fifth, BCNF standing for boys core normal form, right? So that's the kind of a sequence in which they went. So we won't do everything, because this is not a design course, we are basically learning MySQL. But definitely before you move forward now to learn more SQL statements like inner join, outer join, subqueries, you have to understand, why do I need to do this? So today's class is about first, second, and third normal form. So I'll start with the database and tables which are not in the first normal form, convert it into first. Then start with something that is not in the second normal form, convert it into second normal form. Start with the table which is not in third normal form and convert it into the third normal form. And if time permits, then we'll start doing a little bit of join statements, right? So that you know, oh, this is how now I talked to all the tables. This is how I relate all the tables. There is an in-class assignment, but if time does not permit, I'm not giving it. I'm not giving it to take it home and then. So if I have time and you can do it in class, I'll give it to you. Otherwise, we are just not doing it, right? I'll kind of show it to you and tell you how to work around it, but that's it, right? So now the concentration is on join and subqueries. Why do we need to join tables? Because you will just see that as soon as I start designing tables in a database, I have to say, oops, this is not in the first normal form, I have to convert it. And conversion is always splitting a table into more than one tables. That's what normal forms will become. So let's go step by step from first to second to third. Okay, once you have this clear in your mind, then joins and subqueries will make sense. This is just the base, the concepts of what join needs. Why do we need more than one tables in a database? When we design more than one tables in a database, how do we design them? What do we keep in mind? And you will also today be introduced to constraints and foreign key. You're already familiar with primary key, right? Today we'll also talk about foreign keys. Okay, so let's start. So you can open up your toys not 1NF. So this is a table. So let's look at it. Why or is it in the first normal form? And if not, why not? So the normal statements, the normal comments, I've kind of commented it for you so that we don't waste time in class, but just so that you know this is how it has to be commented. I've just called my database not first normal form so that I can remember it and so on, right? You don't have to call whatever I call it, whatever makes sense to you. As long as you have one naming convention, consistency throughout your script, I'm fine with it. But this is how it is usually done. The underscore is used to divide words, not the camel case or the Pascal case convention. So if you want to stick to conventions, I've been sticking to conventions from day one. Right? I just put DB in front of my database, just so that DB stands for database. And then if need be, I can give the same name to my tables. All I do is I prefix them by TBL. Whether you use underscore in them or not depends upon your name. So if it is a long name, I kind of put underscores. If it is a short name like TBL toys, I don't. But it's up to you. It's not a big deal, right? Okay, so let's look at this table. I've populated it with data, and then I've done a select. Let's see. Is this table in the first normal form? I'll repeat the definition of first normal form for you. A table is said to be in the first normal form if 1, it has a primary key, which looks like it has a primary key, and 2, all fields are atomic in nature, right? So you'll say, oh, toy ID is atomic, the toy is atomic, and so our colors are atomic. But if you look at the colors data, there are repeating groups of data. Do you notice how I say that toy number 5, which is wiffle ball, is available? I have no clue what that wiffle ball is, but anyway, is available in white, yellow, and blue. So now I'm keeping this information in one record, right? So, or in other words, if I say all fields must be atomic in nature, there should be no repeating groups of data. But here I see data being repeated. The colors, white, yellow, and blue are kind of the same kind of data, but under a field. Some have 2 colors, some have 3. You could even have a single color. A toy could only be available in a single color. So that means this table is not in the first normal form. You'll say, so what's there? Let's keep it and let's forget about it. What's so big about it? The problem is I have no clue what should be the size of my colors, right? I'll kind of make a guess, 40, 50, 100, but I have no clue how many subfields does this field contain. So if I said, okay, give me all colors for say for a record, or I just said, just show me all colors, but I want to see the colors in different columns when you display them. Now you're saying, are there 3? Are there 4? When you create a select statement, it is not as simple as select color from TBL toys. I want you to break up the colors, show me the colors in different columns, and then I have no clue how many there are. So I'll kind of guess. I'll say, okay, pick up the whole thing, keep splitting it till you have no more, and you can do it. It's just more complicated. It's just more complicated, nothing else, right? So I can write select statements for it. It is just more complicated. Life would be simple if I could have one color per field. So can I just say, okay, let me create fields color 1, color 2, color 3 in the same table? That doesn't seem to be good at all. Again, you still have repeating groups of data and you don't know how many such fields to create because you have no clue. You say maximum there will be 5 colors. Okay, there'll be 5 colors. Then maybe in some records you're wasting 4 fields, 3 fields, 2 fields. So it's not a good design. Logically, if you think about it, it's not a good design. So how do I convert this table into more than one table? As soon as you have to think about convert, you'll have to say, oh, I'll have to do something about the structure of the table. As soon as you think about the structure of the table, you will notice that you will always end up with more than one tables in the database. Then you will have to relate them and then answer your queries. So what do you think I can do about this table? Just logically, nothing related to SQL or whatever, just logically. If I wanted to break up this table into say 2 or 3 tables, what do you think I can do? What should I keep in one table? What should I keep in another table? And then what should I keep in other tables? Like, how will you do it? Can you think of something? Can you logically think of something? If you can give it a try, like I'm just giving it a try, right? I mean, I'm not saying you have to know it because maybe you are not yet used to it. We've never done it, but think about it. If I could keep the toy ID and the toy in one table, that's fine, right? Because each toy has a unique toy ID. And then I could keep this information in another table that this toy 5 is available in white, this toy 5 is available in yellow, this toy 5 is available in blue. If I could keep this information in another table, that this toy is available in this color, not in one field colors, toy ID color, toy ID color, toy ID color, if I can do that. And then now how do I know, then how do I connect the two tables? They are connected by toy ID. So let's see if I can do it one by one, step one at a time. So this is my first step. I'm going to break up this table. So I'm just saving it and I'm calling it as toys 1F. So if you want to keep the not 1F so that you know where you started, keep it and then save it as a different script, and let's see what I need to do. So I need to change the structure of my table. So let's see, what can I do? One, I'll create two tables. So we'll go step by step, and if you think you understand it, good. If not, then please see that you understand. You ask me. Okay, so this is what I'm going to do. I'm going to take out the colors out of it. I'm going to create one table like this. I'm going to say create table TBL toys, right? And it's up to you if you want to start kind of, just because you'll see tables will have many more tables. Okay, that's my first table. And keep in mind, when you split your table and you do select, and you, of course, when you split your tables, you will have to split your data also. Some data will go in one table, some data will go in another table. But there should be no loss of information. You should be able to recombine the data from the two tables to give you this information. So the information that toy ID 5, which is called wiffle ball, is available in white, yellow, and blue, should still be available from that 2 tables or 3 tables or 5 tables or 8 tables I create. So keep that in mind, right? There should be no loss of information. Okay, so that's my table number 1. I create a table in which I just keep the toy ID and the toy. Is it in the first normal form? Does it have a primary key? Yes. It's just an auto increment, so it's really not so tough, right? And 2, it has the toy name. You can call it toy name if you like, if that makes more sense. And this basically is in the first normal form. There are no repeating groups of data. Every field is atomic in nature. So I've done this, but I've lost the information about the colors of the toy. So I need another table. So let's take another table. So again, we'll take another table. Let's create another table now. So this is the process of splitting. This is the process of splitting a table into more than one tables such that each table is in the first normal form. And when you combine the data in this table, you still have what you need. Okay, so let's create another table now. Let's see what should be in the table. So you can call it anything you like. I'm going to call it table colors. And this is what I'm going to keep in it. And this table colors, as the name suggests, though it's not necessary, but always giving good names is kind of good. I'm going to keep the toy ID, which again definitely will be an int, right? And we are not yet done, right? And oh, let's just keep one thing first. Let's create it one at a time. Let's do the colors first. I'm going to create a table with the color ID, and it will be an int, not null, auto increment key. There. This will take a little time, but once you have the knack of it, it's not a big deal at all. And the color, which was when we started. Oops. When we started, it was, what was the color when you started? What was the type? Varchar 10? Okay, thank you. So it was Varchar 10. So I'll kind of keep the same one because okay, so this is what I'm doing one by one. Okay, oops, no comma here and no comma here. Okay, my second table is ready. So definitely before you do this, you'll have to drop the table. Okay. Just kind of follow me in the first couple of examples, then I'm sure you'll be able to do it. So we're kind of, will change my comments.
It was actually Varchar 40.
Color was Varchar 40? Oh yeah, because it was 3 colors. Right, you're right. Thank you. Yeah, so I won't keep 40 now. I'll stick with something like 10 or 15, right? Each color. Now I'm going to give color. This is what is going to happen. One color ID, one color. Color ID 1 is white, color ID 2 is yellow, color ID 3 is blue. So I'm just keeping a table of all colors that toys can be made. Not all colors in the world, but all colors that the toys can be made of. So definitely whoever the factory or whoever is manufacturing this toys knows that I'll be manufacturing toys in red, yellow, green, blue. Maybe those are the 4 colors. So that information will go in a table. So this is the color ID, this is the color, this is the color ID, this is the color. Think how it is, how easy it is now. If the manufacturer thinks now I have to create something in black, all he does is add another record in this table, give it an ID, or I mean automatically if IDs are being given to it, give it an ID 5 and new color black is created. So all the information about toys is at one place, all the information about the colors is at one place. Easy, right? You see how like it's organized. So if the manufacturer says, oh, I'm now going to manufacture another toy, all he does is give it a new ID and add it to the toy. Maybe it's not being manufactured right now, but he's thought about it, it is being done, and there it is, right? And if he wants to create new colors, he'll say, now I'm going to also do colors, my toys in black or orange or whatever. Just add another color and color ID to the table. So 2 tables are in. Right, so both these tables are in first normal form. Information is exactly available at one place, right? It is exactly available at one place, and addition of data, updating data, deleting data, no problem at all. Every piece of information is only present once, right? So if I wanted to select something, what is the name of the toy with toy ID 5? Simple. What is the color with color ID 4? Simple. If I want to update something, toy ID 1 is now no longer kite, but it is baseball, change at only one position. If I want to delete something, only at one position. So when data is not duplicated or replicated, selection, updation, and deletion are simple. And your data will always be consistent. You're keeping information only at one place. So, okay, I have my toys, I have my colors. Now, the third important table. Where will you make this combination that toy 5 is available in white, yellow, and blue? Now we have to keep this information, right? So we have a table which has the toy and toy IDs. We have a table which has all the colors that are being manufactured by the company. And now we want to keep this information that 5 is available in white, yellow, and blue. 6 is available in green and yellow. 9 is available in red, blue, and green, and so on. So I need another table now. But what should be the contents of the table is now important. What should be the structure of the table? Think about it. So let's see. Let's create another table now. So this table is just a process, and you will get it with time. Or practice, I should say, right? Not with time, with practice. So let's drop another table. We can start writing drop table and create a new one, drop table and create a new one. So let's create another table. Oh, so first let's delete it. Again, you can call it whatever you like. I'm going to call it TBL, and just so that whatever is on what I post, or I think I've already posted the complete one. I don't remember. I'll stick to that. Okay, so I'm going to create a table, toys and colors. Just because I'm going to keep what toys are available in what color. Think for a minute. What should be the structure of this table? So that you have this information that 5 is available in white, yellow, and blue. What should be the fields of this table? From where should be they drawing their values, such that if I combine all these 3 tables, table toys, table colors, and this table's toys and colors, I get all the information that I have right now. What should be in this table? Give it a try. Think about it.
Toy ID, color ID.
Perfect. Toy ID and color ID. That's it. Think about it. So Ratan says put toy ID in it. So toy ID, it's an int. We won't complete it. Don't kind of go with auto increment. It is not on an auto increment. It's an int, right? And what is the second field you're saying? The second field, and of course we'll say not null. And the second field you are mentioning is color ID. Again, it will be an int. You can kind of make it neater. That way it's easy to read, but it's up to you. It's again an int. And it is a not null field. That's what Ratan says. He says, if I can create a table in which I can keep toy ID and color ID, what do you think will be the first record of this toy ID, color ID? 5 and maybe 1. So if my colors are white, yellow, blue, and green, so on. I'm just kind of thinking first color is white. The information I'll keep here is 5 and 1. 5 and 2, 5 and 3. That's all my table will contain, right? Anytime you want to say, what is this table 5 and 1? 5, go and pick up from the toys. It will tell you it's wiffle ball. 1, go and pick up from the color ID. It will tell you it is white. So you know that 5 is available in white, right? Now that looks okay. But what are the restrictions on this toy ID and color ID? The toy ID of this table must be a valid value coming from the toys table. The color ID in this table must be a valid color coming from the colors table. You can't just put any toy ID and any color ID. You can't do that, right? So now let's learn about how do you create this rule or this constraint that the toy ID value must come from the toy table and the color ID value must come from the color table. Otherwise, your records could be wrong. I'm writing 9, 9. There is no toy with ID 9 and there is no color defined for 9. It's useless, right? So now how do you do that? That's what you have to learn. So you are going to create, you can write it after the field or you can put them at the end, whatever works for you. I prefer to put it with my field name because it just makes it easy for me to understand. I'm going to create a constraint. They're called constraints. Constraints. I'm going to create a constraint. My spelling is wrong. That's why it's not changing. RAINT. I have to change into a reserved word. There. I'm going to create a constraint on this field. A constraint is just a rule. You're constricting it. You're saying this is the rule that applies to it. And the constraint you are going to apply works like this. You'll have to give it a name, right? I'm following, people follow different conventions. I'm going to give it a name called C1, C1, C2, C3. Usually these names are more descriptive. So something like toys and colors. So they keep the name of the two tables that are being kind of referred. It becomes too long. I'm going to keep it small because again, I'm trying to explain what I'm doing. I'm going to create a constraint called C1. I'll just put FK with it because it's a foreign key. So now toy ID is a foreign key. So what is a foreign key? A field whose value needs to be drawn or its value has to come from another table where that field is a primary key, right? So toy ID is a primary key in the toys table. What I'm saying is that this toy ID should draw its value. A valid value for toy ID has to come from that table. Okay, so let's complete it. So I'm going to create this constant or this rule, and this is how you write it. You are saying that my toy ID is a foreign key. So this is just the name of the constraint. This is the foreign key that you're creating. You're creating a foreign key called toy ID. And now it references the toy ID of which table? There. That's the constant you have. Oops. Is it a comma? No, cannot be a semicolon. It's a comma. That's how you define a constant on a foreign key. So you could have taken these 3 lines from 33 to 35 and put it at the end of the table. Of course, before the create table command finishes, before line number 37, it's up to you. It's my personal preference that I kind of write my constants after my field. That way I know what it is going on. Please keep in mind, this toy ID, you could have given it any other name. Doesn't matter. It really doesn't matter. But this relationship is important. You are saying the toy ID, this toy ID that I'm defining is pulling its value, is referencing the table TBL toys and the toy ID there. These fields could have completely different names. Doesn't matter at all. It's not the name which is binding them. It is the rule which is binding them. Keep that in mind, right? So you could have called the toy ID in the toys table whatever you liked. You could have called the toy ID in this table whatever you liked. You don't have to give them the same names. But the rule says that this toy ID in this table is a foreign key which is referencing values in the toys table. The rule is important. Okay, so notice this name, this toy ID is talking about this one, and this toy ID is talking about TBL toys table very clearly, right? So it says I'm going to refer the toy ID of the toys table. Rule done. So you cannot insert a record that does not have a valid toy ID. What about the second one? What about the second rule now? You'll have a same kind of rule. All you will say is now my color ID is a foreign key and it is taking its value from the color ID of the colors table. So complete it, create it, create a constant. The constant you can call whatever. I'm going to call it C2 FK just for foreign key. So now you have another key called foreign key. A foreign key is a field whose value has to refer to or drawn to from another table where that field is a primary key. Okay, so you formed a rule. Okay, what is the rule? It says that this color ID is a foreign key, right? And it is referencing, so it references note it is one single statement. You could put it in the same line if you want. You could have put them in the same line if you want, but remember the comma is coming at the end of the statement. So, and what is, yes?
There's no underscoring table toys when you're referencing it?
I created one. I added one. I changed it. Just so that there was symmetry in this script, right? Yeah, there wasn't in the first one. You're right. There wasn't. Okay, what doesn't it like yet? Oh, the comma, because I haven't yet finished it. Why I did put a comma? What is missing in this table? It's not in the first normal form. What is missing?
Primary.
The primary key. What do you think should be the primary key of this table?
Toy ID.
But toy ID is not unique. 5 available in color 1, 5 available in color 2, 5 available in color 3. Colors are also repeated. 5 available in 1, 6 may be also available in 1. But the combination toy ID and color ID is unique. There is no other record. There is nothing else in the record at all. So you could create a new primary key, which is auto increment. But like this table has nothing else except a toy ID and color ID. So the key of this table is toy ID and color ID combined. This is the first time you're seeing a combined primary key, but it is a valid key. There's nothing wrong in it at all. So the combination is unique. Is it unique? 5, 1 is not occurring again. You're not giving that information again. You're not repeating that 5 is available in 1. 5, 2 is different from 5, 1. The combination is unique. 5, 3 is different from 5, 1 or 2. So you could create an auto increment key for this table because that's the easiest thing to do, but it's useless. Like there is no other piece of information. There is no third field. There are only 2 fields. So if I want to refer to this table, I'll always refer it as a record, which toy in which color. So if I'm referring it together, there is no third field. What's the sense of creating another primary key? So the primary key is toy ID and color ID combined together. So can a primary key be more than one field? Of course, it can be. I've said it is a field or a combination of fields that uniquely identifies each record of the table. And this combination is unique. This combination is unique. Now your next job, the structure is ready. The structure is ready. What is it showing? Why doesn't it like comma, 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 comma? Okay, let's see. If it still gives me something, then I'll have to think about it. Did I? Okay, that's one, but do you think that could be the problem? Syntax errors, but yeah, sure, could be. No, it's still giving us quickly. Okay, we'll see. Sometimes I just have to save it and run it and then it comes fine. I don't see any error kind of syntax wise, but you know, syntax errors can, you think they are not there and sometimes you are not paying attention. Commas are at the right place. Semicolon is at the right place. There is an opening bracket. There is a close. Oh, what the, I've put this in the instead of the, oh, this is the problem. because I talk while I do it, and sometimes I'm not talking faster than I'm writing. Oh, that's the problem. I'm saying, what is the problem? It's right, because I put it with the drop table. There, sorry about that, guys. Right? So the create table statement was missing. That's why that's the biggest problem. There, saved. Now we are okay. So I'm dropping tables and I'm creating new tables. We already know why we drop tables. And again, you can just put a comment, drop the table if it exists. So you can start putting comments if you like. I'm hoping at this point of time you can do it. And if you don't mention names, you can just copy the same comment and put them in all the, so you save yourself time. And again, it's just a comment for a section. Okay, now my table structure is ready. So please give it a thought for a minute. I've created 3 tables. I had 1 table. You're saying you're increasing your work. Yeah, I am. I have more than 1 table. So I'll have to start using joins when I select data. But I'm following the rules of normalization. And believe it or not, if you don't follow them, down the road, it is going to create problems. Problems in selection, updation, deletion, everywhere. Right? You will have problems everywhere. You will get too complicated select statements. When you update your record, you may have inconsistency or data integrity will be lost. And of course, the same with deletion. If you have data that is not in the normal forms, you will have problems in all these operations, right? So, and the first normal form is the minimum. It's the minimum requirement. Definitely when programmers or designers design tables in a database, they don't stick only to the first. They go all the way to the end of normalization, because they know that these rules were created because research has been done that otherwise the tables are not well designed. Definitely down the road, they will create problems in all these operations. Okay, now how do I populate the tables? Now I have to populate them, right? The tables are ready, so the design is done. I've designed it. I have to keep all this information with me in such a way that it's all there, though it is in different tables. Start with me. What do you think I should be doing? Let's create them one at a time. Let's create the TBL toys first, right? We'll put a toy ID, we'll put a color. So kind of we'll start breaking it here. For now, don't remove the rest of the things because we'll need it in the next table. So don't remove them, okay? So you can comment them out if you want, but we will be removing them. Of course, this is not the right way of doing it, but let's insert into the first table now. You said my first table will consist of a toy ID and a toy, right? And that's exactly what I've done. So I've said 5 is called wiffle ball, 6 is called frisbee, 9 is called kite, and 12 is called yo-yo. I could have just ignored 5, 6, 9, 12, but I have to keep the same data. So I'm just keeping it. What is your second table? What should I keep in the second table? Let's populate TBL toys. Or let's populate the toys table. So that's 1. Let's do the second one. Populate the colors table. Okay, what should I put in colors table? We'll have to say insert into, I think we called it TBL colors. The 2 fields were color ID. And again, if you don't want to do color ID, you can just leave it alone. Maybe in this one, let's use the auto increment because there was no restriction in the previous data. Let's just say insert into table ID. What was it called? The second one, color or colors? What did I say? It should be color, but I mean, I don't know what I called it. Color. I did say color. So let's use the auto increment in this one just because there are no previous values given. Okay, so what will you put into it? I'm going to put colors. You can choose whatever sequence you want. I'm kind of just going white. That's my first one. Oh, mama, I'll just kind of pick up all colors, but only once. So white, yellow, blue. I'm just going the sequence, okay? You can do anything you like, as long as you have all the colors. Green, yellow. That's why I didn't remove it at that point of time, because I needed those colors. Anything missing? Red. The sequence is not important, but that you don't lose any data, that's what you have to remember. Okay, so white, yellow, blue, green, yellow, red, blue already done, green already done, white already done, yellow already done. Okay, remove. Remove, remove, and remove. The colors ID table is ready. Each color is occurring exactly once. 2 yellows? Can't have 2 yellows because color ID, I mean, I have to keep that each record, I mean, there are unique values, one color ID, one color. Have I missed something else or are we okay? White, yellow, blue, green, red. Okay. And again, nothing restricts you. If you want to add another color, though it is not available in a toy yet, and the manufacturer says, you know what, I'm thinking of adding the color orange to my list here, no problem. If he says, I'm going to now manufacture another toy, no problem. So you're not restricted. In the previous one, if a color was not being used, I couldn't create a record for it. If a toy did not exist, I couldn't create a color for it. But the manufacturer now can do things. He can say, okay, I'm going to now manufacture baseballs, right? Or maybe baseball bat. So he can keep this information in the table toys. There are no yet, he hasn't thought about new colors. He'll say, okay, maybe in the same colors, but usually it's brown or whatever cream. Then he'll say, okay, let me add. But there is no restriction. Like he doesn't have to create a complete record in the data. He just is keeping this information without affecting. Maybe nobody uses 12 YOU. That's fine. Maybe nobody uses orange yet, but that's fine, right? So the information can be added to the tables and it may be used in future, but it's as easy as just adding a record. Like I just did, I added orange. It was not in my table. But if you don't want to, you don't have to. But if you want, it's as easy as adding a record. It doesn't harm anybody, right? It's adding more information. So my 2 tables are ready. Right now, these tables have yet no information about which toy is available in which color. We haven't done that at all, right? So now that's my 3rd table. So now let's populate the 3rd table. And this table was toys and colors table. These are just comment. You needn't use the names like these table toys, or if you want, sure, no big deal. Okay, so let's insert. Let's insert into table toys and colors. Okay, what are the values that need to be inserted? You help me now. Without losing that information that what color, what was available in what color. That's all we need, right? Okay, so wiffle ball was available in colors, I think 1, 2, and 3. That's my first record. That's my second record. That's my third record. I think there were 3 colors for wiffle ball, right? White, yellow, and blue. Just so that I know what else was available. So I've done this. Wiffle ball available in 1, 2, and 3. Frisbee in green and yellow. So frisbee is 6, green and yellow. Green 4 and yellow 2. Doesn't matter. The sequence doesn't matter. You can say 6, 4 or 6, 2 and 6, 4. That's frisbee. Green and yellow. That's my sequence, right? If you have a different sequence, you just have to be careful. So green and yellow is frisbee. Okay, let's go to the next one. I'm picking it up from here. Kite, which is 9 in red, blue, and green. Red, blue, and green. Red. 1, 2, 3, 4, 5. Blue. 3. And green. 1, 2, 3, 4. There's the kite. Information on kite is here. Right? Just a bunch of numbers. You'll say, oh, that's so difficult to read. I have no idea what they are. You don't have to read them like this. I'll give you a very small example of how I can show you the original table. Okay, I can. Okay, let's go to the next one. The last one was yo-yo in white and yellow. Yo-yo was 12 in white and yellow, 1 and 2. There. The table completed. I want to add information about a new color. Go to the color table. I want to add information about a new toy. Go to the toy table. He has not yet, the manufacturer has not yet started manufacturing it, hasn't thought of the colors. No, at least add it to his toys table. He's thinking, now I'll create a baseball bat or whatever, right? It can be done. So this table is something that should work fine. So if you want to do just for the heck of it, let's do TBL toys, just to show you the data, right? Let's do a select from TBL colors. Let's do a TBL toys and colors. Of course, you can describe your, see the description of your record, of your tables. You can show the tables, you can show create command, whatever you like. All those are just extra, right? Give it a go. Save it and give it a go. Oh, error code doesn't match count at value 1 into table and colors. Into table toys and colors. Oh, sorry, copy and paste. No, oh, yes, copy and paste. Okay, so what is it? It's called the toy ID and color ID. Of course, it doesn't match the count because I copied and pasted and didn't change it. There, that's your third table. You're putting in two values. And notice my error. Column count doesn't match value at row 1. It is saying, you are saying there are two values to be inserted. And here there was only a field because I had copied the insert statement and not made the change. There, let's try it again. Give it a go again. There you are. Table number 1, table number 2, and table number 3. These tables sitting alone don't make a lot of sense. Where is this information that 5 is available in color red, yellow, white, yellow, and green? You will say, am I to infer it from this table, 5, 1, 12, 1, 5, 2, 6, 2? That isn't making sense to me at all. Right? To a common man, if you show that table, can he or she figure out anything from that table that 5 is available in which colors? No, not. So what do you need now? Now you need a select statement that will join these tables. And after they join, it will extract data from these tables and show it on the screen. Right? I can do it for you. I can show you this statement, but we are going to do them in detail when I finish all my 3 normal forms. But it can be done. Maybe at that point of time when you do it, we'll come back and say, now let's do it here. Right? So we'll do that. So these tables, all these 3 tables are in first normal form. They all have a primary key. All fields are atomic in nature. There are no repeating groups of data. And I have not lost any information, guys. You have to keep this in mind. This is very important that you should not lose any information. Your information, you should be able to keep information about toys in the toys table, color ID in the color table, and what is available in what color. Can I do this? Logically think about it. I'm just going to write a new insert statement. And you tell me what could be wrong. I'm going to insert into toys something called 13, 1. Do you think it will work? Exactly. There is no toy ID. If I hadn't placed that constraint, I was okay. But because of that constraint, it's going to say you cannot do an update or a foreign key constraint is in effect. You can do this because 13 is not a valid toy ID. You cannot do this. So this won't work. Since 13 is not a valid toy ID. Remember, this is your constraint. It's a foreign key. Your toy ID is a foreign key. So its value has to be drawn from a table where the toy ID is a primary key. It won't work. Right? What do you think about this? So we'll have to figure it. I mean, of course, I'll have to comment it out. Otherwise, I can't make it work at all. Let's try this. Yo-yo in 13. Do you think I can do this? Not again. 12 is a valid toy ID, but 13 is not a valid color ID. Right? So none of this will work. It won't. So don't forget your constraints. If you forget your constraints, then of course it's all useless, right? You can put in records that had no existence. You're trying to put in a toy that does not exist in the toy table. You're trying to put in a color that does not exist in the color table. You can't do none of these. And this is because you've created those constraints about foreign keys. So now you've learned a new concept today about foreign keys. So a key, a field whose value is drawn from the values that are available in another table to which it is referring, and in that table the field is a primary key. So this will work. Now if you run it, nothing is wrong, everything is fine, and it should run as it was running. So our next question will be, okay, we've done it. We've split the table. It's where it should be. The data has been put in the right tables. Our next question will be how to extract that data. So we'll keep the extraction a little ahead, right? We'll come back to it. I just want to finish off the normal forms first. So is that clear? So that's how you convert a table that is not in the first normal form into tables that are in first normal. It will always create more than one tables.
So now that we know that you can use two separate fields as a primary key together, which is better practice? Because a lot of the tables that we could have done before, we could have used two fields.
No, not what we've done till before. You could have said, oh, the combination of last name and first name could be a key, but not necessarily. It's not always unique.
Or so, last name and program or something like that.
Yeah, but not necessarily. But yes, why did we do it? Because there was nothing that worked at that point of time. But what is the usual practice? People are lazy. They just create an auto increment field.
Yeah. So
that's what they do. But example, student ID, right? Why wouldn't we use it a primary key? Because if you are going to refer to records through the student ID, I would make it a primary key, because otherwise, how will I know 1, 2, 3 stands for what? Yeah. So you'll have to think logically with intelligence and depending upon your application.
Okay, so if you can avoid
the auto increment and find a good primary key in your table, use it, because your select statements will be based on it. But if you're not basing your select statements on those primary, on that field, then just do an auto increment so that it is in the first normal form, right? So it will really depend upon your application. So if you're doing a lot of, access of your select statements are based and they are saying, oh, I have to always use the primary key, I would definitely make a primary key from the table. But if it's just to convert it into the first normal form, I'm not doing any selects on it or anything, I wouldn't bother. Okay, but yes, the combination, it's not always easy, though you think it may be. It's not always easy to find a combination. It's not. But yeah, sometimes it's really easy, like this one. It's quite obvious that the toy ID and the column ID and the color ID together should be a primary key, right? Okay, so that's the table is in the first normal form, complete. We'll come back. The selection will come back. Let me just do this, right? Then we'll talk about joins. Okay, now please pick up the one which says not in the second normal form and open it. And before you go on, you definitely have to know what is the second normal form before we convert it. Okay, so let's look at it. Normal, I haven't put any comments just because I'm sure you can do it. Okay, so this is a database not in the second normal form. It is the one that we just created, but with a little more, right? I have a TB table toys. I have a primary key toy ID. I put in values into it. I'm just doing it, right? Then I have a toys other, which has everything else. In that everything else, I have a toy ID, which is taking its value from here. And what I have is, where is this toy available? In which store is it available? And what is the address of this store? And what's its inventory? How many of these toys are there? So let's pick up another example. Again about toys, just because they were all kind of together. Okay, third, we'll change the third one. Okay, so let's look at these two tables one by one. Let's look at the first tables. Is it in the first normal form? Yep. There is a primary key, yes. Yes. Are there any repeating data groups? No. Every field is atomic in nature. We are fine. This table is storing information about toys. what is the toy ID and what is the color, what is the name of the toy. Everything looks okay. We are fine. Okay. This table is also in the second normal form for your information, but let's talk about what the second normal form is. Now let's look at this table. Is it in the first normal form? I have a primary key. This toy ID and store ID combination I've made as the primary key. What is this information? Look at the table and it says toys other, right? Toys other says other information about this toy. So this toy ID is available in this store in this amount. Inventory is amount, right? You can change it. The inventory doesn't make sense to you. Just say number or amount or whatever, units, whatever you like. Now this is about the toy. It says, so if I want to say, oh, can I find, so you go to, I don't know, you go to maybe Toy Stress and you say, I'm looking for this, you don't have it. They'll usually go to their computer and look up and say, oh, this is available in Toy Stress at New Market. They can give you this information because they're pulling out information from here, right? They're saying that this toy is available in this store, which is in New Market, right? So they have this information somewhere in their database that this toy, and they'll also tell you the number. They also tell you the number, right? I don't know how many times you've done it, but like it's common. Right? So you go and you say, I want this, but your store doesn't have it. They'll say, give me a minute. Oh, it is available at that store in that location, and there are 5 of them still there. So there it is. So that information is available. Quite logical, you have it somewhere, and this is the table I've created for it. Okay? It has a primary key. Now you have to think, do I need a primary key? Definitely in the first normal form. The combination of store ID and toy ID is unique, right? So this toy in this store, these IDs are unique. So this combination is unique. You could have created an auto increment key, but I'm trying to now show you how, if you have a table, you should start looking at fields that can together act as a primary, like a primary key. Okay, now, is it in the first normal form? Yep, looks like in the first normal form. It has a primary key, yes. All its fields are atomic in nature. The store address, you could say, oh, what if the address is the street number, the city, the whatever. But remember, we said it is atomic in nature if it need not be broken up or it's already, right? So for me, the store address is not important. It's fine. I'm not saying it has to be kept in 4 different fields, street and city and country and so on. I'm okay with the address. So it is in the first normal form. Everything looks okay. I've created a constant on the toy ID, very rightfully so, because this toy ID has to draw its value from the toys table. Can you think of something here that doesn't look right in terms of dependencies? Is the inventory dependent upon toy ID and store ID? So that's my primary key. So let's look at the non-primary key fields. Is inventory dependent upon this combination, toy ID and store ID? Yes. Is the store address dependent upon this combination? No. What is it dependent upon? Only the store ID. So something doesn't look right in the table. Right? It is in the first normal form, but it is not in the second normal form. A table is said to be in the second normal form if it is already in the first normal form and every non-key field means something that is not taking part in the primary key, is wholly dependent upon the primary key. But here we see a partial dependence. We see that store address is partially dependent upon the primary key since it only depends upon store ID. So you say, what's the big deal? Like, what is it creating? What problems is it creating? Let's look at a problem now. So a new store has been opened by Toys R Us, right? The new store is being opened at Kandal's. There's a lot of construction going on at Kandal's. New stores are opening, right? Shoppers opened and Zaire's opened and whatever. They know that this is being opened, right? So they keep this information about this store is opening at this store ID 5 is opening at Kandal's in their table of stores, right? But there's nothing yet. They haven't yet put anything in it. There are no toys that have gone in it, nothing. So there is no inventory yet in it, but it is coming up. So this information that a new store is opening on Kandal's in the North Berry, they can't keep this information. They can't keep this information anywhere because where do they keep it? They can't keep it in the toys table because it's about toys. They can't keep it here because there is yet no inventory in their store. So this information cannot be kept. So this problem, you can't insert data. Useful data cannot be inserted. They want to insert this data. They can make up a fictitious record. Toy ID is 1 and inventory is 0, and they can put it. But why? Like, why do something that can be done in a better way? So information about a new store ID and store address cannot be put in this table without a toy ID and inventory. Cannot do it. So design doesn't seem to be good, right? If a non-key field is not fully dependent on a table's key field, why are you keeping it in that table? Why? Why don't you put it in another table where this information can be put independently? The non-key is dependent upon the primary key and you can add information. Okay. So, and another thing, let's see. Suppose the toy ID 1 is available at store ID 1 in inventory 5 and you keep the store address with it. Toy ID 2 is also available in store ID 1 and you're again keeping the address. Why are you repeating data? So data will be repeated. So now let's look at the problems of data repetition. A store could have more than one toys, definitely. So toy ID, store ID, toy ID, store ID, that's fine. 1, 1, 2, 1, 3, 1, 4, 1, it's all fine. That combination is unique. But for store ID 1, the store address is repeated 4 times. Now, if I have to change the address of this store, for whatever reason, the store address is changed, right? Whatever reason, it's a silly reason, but suppose the store ID needs, the store address needs to be changed. You have to change the addresses in 4 records. That doesn't make sense. At one point of time, the first record is being updated and you haven't locked the table. Somebody comes and looks at the data. There is a different address in one record, there is a different address in another record. Data inconsistency, data integrity is lost. Though you don't update openly, you always lock the table, update, and then open the table for use. But think about it. Data integrity, so every time you need to update something, you have to be careful that you have updated in every record. So wherever store ID is 1, please update it. You'll say, how does it matter? Let it update it. But imagine you're wasting time. The address which is dependent upon just the store has to be updated at 4 places just because of the structure of your table. Doesn't make sense. If you want to delete the store is no longer your valid store, it is closed. Aeropostale has closed down in Canada, right? You have to delete those. Suppose the Georgian Mall has closed down. You'll have to delete that information at 1 record, 2 records, 3 records, 4 records, God knows how many records, as long, whatever it is. So you can add new information, you can delete some information because it's, you just have to do it at more than 1 places. For updation, you have to do it at more than 1 place. So imagine, as soon as you have data being duplicated or replicated, problems arise in updating the data, inserting the data, deleting the data. And that's not how it should be in a database. Because remember, a table has trillions of records. It's not small. It's not as if, oh, it can be done in a minute. You know what I mean? Like when I say minute, I'm not saying minute. Like it doesn't matter. It matters. The design matters. So what do you think you can do to convert this table into a second normal form? So there is the definition of the second normal form. I have just described the table. I have inserted some data into the table, right? Just normal. And I've said insert into toy ID. I've tried to insert a toy ID that does not exist, like 10. Of course, I can't do it because there is a foreign key constant. And then I've shown you the tables. So right now, this is how it looks. Oh, right now, this is how it looks. Everything looks okay. Those are the tables. That's the data. That's the data in my first table, and that's the structure of my first table. So they look okay. But here is the problem that when you have repeating 1 and 1, 23 Maple at 2 places, 2 and 2, 1902 Amber at 2 places, 4 is at 2 places, doesn't make sense. Something is wrong with the design. It's not the right feeling. So if for whatever now I have to change the address of store ID 1 from 23 Maple to 23 Maple View Drive, I have to do it at 2 places. You say, what do you have to do? Put an update statement and it's done. Yeah, but imagine if there were trillions of records, it has to browse all the records, look for that store ID 1 and change the address. Not done. Doesn't make sense. If you could keep this information somewhere else, this store ID has this address, update only at 1 place. Right? So why would you do it? If I have to delete for whatever reason, so this store is going to close, right? This store is going to close. The inventory, there is still inventory here. So now I want to just say this store is going to close. I have to delete records at 5 at whatever. You say, but yes, they all have to be deleted. Yes, they have to be deleted. But if I could just delete the store for now, it is no longer going to be in future. I can only delete it from another table and then let it stay till the inventory is 0, right? So everything will create problems. Everything will create problems. Okay. And when I say everything, remember there are 3 important operations in databases: select, update, delete. So what should I do? We'll have to change the structure. And again, keep in mind, change the structure of the table, redistribute your data in such a way that there is no loss of information, right? So let's save this and let's now help me convert it into, the second normal form. Okay, so I don't have it. Let's save it as. So I'm going to do a save as, and I'm going to say it is now in the second normal form. Okay, now help me. What should I do? Definitely, whenever you have to do something like changing it into a different normal form, into a next normal form, there will always be splitting of tables. You'll have to create new tables, right? So when you create new tables, you keep in mind, in the new table, you have to keep in mind that it should be in the second normal form. You should have a primary key and also follow the definition of the second normal form. Otherwise, if you're splitting it and your new table or tables are not in the required normal form, you've lost it. So what should I do? So the first table is okay. It's already in the first normal form. It is already in the second normal form. I don't see any problems with that all. Toy ID and toy name exactly occur at one place. No problem at all. The problem is here. The problem is in this table. What should I do? What should I remove from this table so that it becomes in the second normal form? Remove what from this table? Which field should I remove from this table? What was the field which was causing problems? Let's remove it. Right? Let's just remove it. Because that was what was causing the problem. But I have to keep this information somewhere. I can lose it. So what do? Create another table. Create another table. Create it. Call it whatever you like. If you want to follow the same names I am following, I'll just kind of change the names. I'm going to call this store inventory instead of others. Doesn't matter. I mean, we have to change everything. So when we put in data, you don't have to, but remember, names should tell you what they are or whatever you like. Okay, so that's one. And let's create another table. Just you can call it whatever. I'm going to call it store information. So I'm going to create a table. Oh, we'll have to drop it also. It's giving me just store info, right? So let's drop the table. We'll have to change it there also. So you can take this definition kind of and leave it here if you want so that you know what it is, but that's what I'm doing. I'm going to split it. So this is called store inventory now. Okay, and I removed that field that was causing the problem from there. What will I do? I'll put it in this. So let's create this table. So definitely think about it. What should I be keeping in it? Definitely that store address that I just deleted from there. Oh, I lost it. Okay. That field was something to call. Okay, where is it?
Store ID, store underscore address.
Okay. So it was store address is what it was called?
Store underscore address.
Varchar? Lost it? Not in second normal form. Store address. Varchar 30 not null. Okay. I've kind of copied it into another table, which is called table store information. What else should I be adding here? The store ID. Right? And that store ID, let's see what it was. It's an int not null. right? Create, oh, comma is missing, semicolon is missing. Okay, so that's the new table I've created. That's the new table. I said this store address, which was only dependent upon the store ID, let's move it out. Let's move it out from the store inventory table and let's move it to another table. So I've moved the store ID and the store address here, right? So at this point of time, this is how the table looks like. I have a toy ID, I have a store ID, and an inventory. So that table looks okay. What am I missing there now? That value of store ID has to come from this table, right? So I have a toy ID there, I have a store ID there, but this value of the store ID has to come from which table? From the table store information. So please add that. Again, as I said, if you would like to, you can put all your constants at the end, whatever works for you. So create another constant here. Let me just copy and paste, will make it a little easier. Okay, so what's the constant? Give it a different name, please. You'll say, why do we give them names? One, naming, right now it may not be so useful for you, but in your second course, if you want to change this constant to something else, it has a name and then you can just change it. You can always change constants. You can update them. You can alter them, right? Okay, what is it? It's a foreign key. What, from where is it taking its value? Store information. I think that's what I called it. Store info. Which fields is it referring? The store ID. There. So as soon as you create a third table, these values of the store ID now have to come from that table. Right? So this is what I've done. I split my table, which was called toys other. I just changed its name just so that, because it's not others now, because I've kind of keeping the information only about the inventory now. I'm keeping the information about inventory here. So the toy ID, the store ID, and the inventory go in one table. Go in one table, right? And the store and the primary key doesn't change. And the new table, what should be the primary key? That will act as a primary key. Store ID is a primary key. And the new table has a store ID and a store address. And now all three tables are related. The inventory is picking up its toy ID from the toys table. It is picking up its store ID from the store info table, and the inventory is its independent value. All these three tables now are in the second normal form. They're now in the second normal form. So I'm not sure if I change the comments here. So we've changed it. These are all tables are in first normal form. So you can just change your comments as you. That was first normal form. First normal form was complete. Now this table, all these tables are in second normal form. They're now in the second normal form. Let's look at them once again. Let's look at them once again. Table 1, second normal form. Yes, because it is already in the first normal form and every non-key attribute is fully dependent upon the key. It's in the second normal form also. Of course, we'll have to, this we won't have to change because we didn't do anything to this table. So this insert remains, the data remains. 2, this was the table that was creating the problem. So what did we do? We removed the store ID from here, store address, and this is the table we created. Is it in the second normal form? Is it in the first normal form? Yes, it is in the first normal form, and every non-key attribute is fully dependent upon the key. It is in the second normal form. Let's look at the third table. Is it in the second normal form? It is in the first normal form because I only have 3 fields, toy ID, store ID, inventory. I have a primary key, all fields are atomic in nature, and every non-key attribute is fully dependent upon the primary key. Inventory, you can't say inventory only depends upon toy or inventory only depends upon store. Inventory depends upon the toy and the store together. So it is also in the second normal form. All your tables are now in the second normal form, which means, so you can leave the definition if you like, and we can remove this because they are now in the second normal form. All tables are in the second normal form. Now, Definitely we'll have to change the data. What should I be removing from here? The toys other. So let's do a control F and look for this table called toys other. So let's do, we have to now keep the data, right? We can't remove the data. Okay, so this is what I'm going to do. And the new name was table store inventory. Okay, let's replace everywhere. Okay, so I have the new table. I'm describing the describing now you can describe all tables if you like. You should be describing all tables. You can put them right after the table if you like, just so that you see them. You should be describing your tables. It's always a good way of checking that things are okay. So I'll do the describe for you everywhere. Whenever I create a table, I'll just describe it. You don't have to, again, it's up to you. When you're a programmer, you have to be sure that everything works right. And then the third table that we created was store inventories was the third one was. So I've just described all the tables just so that you have the description. And you can again show the tables in your database so that you know these are the tables and so on. We'll do a select at the end. Okay. Okay. Now, so this was my table before. I had a store ID, toy ID, store ID, inventory, and store address. I want to remove store address from everywhere. But before I remove it, what do I want to do? I want to save this information somewhere. So let's do an insert here. So I'll take these inserts that are already here. Take a control C or control X and put them after the table. I mean, just one behind the other so that you have them. Insert it here. Okay. And then now create your third table. So let's do an insert here. So insert into your third table was called store information. And we will only store, if you already have data, you have to be careful that, oh, I need to store this ID here. If you have it, then you'll have to do it that way. So we already have the store ID in the other table. So I'll have to keep that and the store address. Just because I have it, right? If I didn't, I would use my, like I could put in any values, but I have to. Okay, so we have some records. I think we had 4. I saw 1, a 2, and a 3, and a 4. Oops, everywhere wrong. I'm going to insert the data here. What do we need? We need the store ID. So let's look at it. Remember we had this table. We already ran it once. So let's look at it here. We have a store ID 1, a 2, and a 3, and a 4. The 1 is 23 Maple, 2 is whatever 1902 Amber Line maybe, 3 is whatever Northeast, and 4 is 17 Angleside, right? I don't know. It's not angle. It's maybe I don't know. A-N-E. Okay, so let's put it. So let's add this data without much work. So we have 1, 2, 3, and 4. We have 4 of them. And then you can copy the addresses. We have a 1, we have a 2, we have a 3, and we have a 4. In the first one is the address. You have them here, okay? Is the 23 Maple. Copy that, that's 1. And put it here in your table. Right? So remember, if I had started with the right design, I wouldn't be doing all this copying and pasting. If the design was right. But of course, once you know, then you won't make a mistake. 2 is this 1902 Amber Line. Let's remove this. We'll remove them afterwards in a minute. I just want to copy them. That's 2. 3 is the 100 East North Street. That's the third. I'm just, whatever information is available, I'm just copying it. And lastly, 4th was the 17 Angle site. So where are you there? Okay. So there are 4 store IDs and 4 addresses. Now, if a new store is going to open, you have not yet stocked it, there is no inventory in it, you can only add that information here and you're okay. You have a place to add information, and in the previous you did not till you had an inventory and toys or whatever. Now I have it, I can do it. Same way, toys information needs to be added, you can add it in the toys table. New toys are being manufactured, they have not yet been sent out to the stores, you can add it in that table. You couldn't do that, like you could, because that table was already in the second normal form. But now I'm not dependent upon, so this is something new. Now, go back to your first table that we have changed, and from the insert statement, remove the address. Remove the address. That's gone, right? This field is gone. Remove the address. Okay, and remove the address. So I have toy ID, store ID, and I have inventory. Remember, you cannot insert a record that does not exist. You cannot insert you can make a note for yourself. You cannot insert with an invalid toy ID, you can do that, or invalid store ID. When I say invalid, that means they don't exist in the other table. That's what invalid means. That is, they don't exist in the referring tables. You can do that. We know that because it's a foreign key. So any valid value, try anything and it won't work. Try it instead of 5, 6, 9, and 12, put something like 13. It won't work. Instead of in the store ID 132, just change the 1 to 7. It won't work. It just won't work because you've laid this constraint that the toy ID must come from the toys table and the store ID must come from the store information table. Keeping this information, I haven't lost anything. All my information is where I just took the information and I split it, right? And now if you want, we can remove this. I mean, you can try it. We've already done it in the previous one. And the last one also show the table from the store information table. Everything has been done correctly. No information is lost. Of course, you'll have to combine this information, but no information is lost. I can add new information. That's a plus point. There is no duplication of data. There are no problems in update or delete. Or select statements will not be complicated from the same table. They will be complicated in another sense that you will start joining tables, but that's not complicated. It's just thinking what's matching. Again, please keep in mind the names of the fields, foreign key fields, don't have to match the names in the primary key. They don't have to. But the rule is important. You are saying this field is a foreign key in the present table and references another field in the other table. Those names are important. So it doesn't matter whether you call them toy ID in the same table. You call them store ID in both the tables. It's not necessary at all. It's the rule which is important. Why do we keep them same? Because it just makes it easy. Right? So it's easy to kind of understand that there is no rule at all. They could be entirely called something in one table and something different in another table. If everything looks okay in this, we should be able to run this script. And we should have our, somewhere we've lost it. I have a problem somewhere. Cannot add foreign key constraint. Oh, I must have missed something while I did it. Okay, let's see. Cannot add foreign key constraint. Toy ID int not null, constraint toy ID refers to toy ID, store ID int not null, constraint store ID, store information. Oh, maybe, you know what? I think I know. Maybe it needs to see the definition of the table before it says, I'm not sure sequence wise, but I'm going to try it. I'm giving it a go, right? I'm just trying it. That is what is causing the information. Maybe it doesn't see the definition of that and therefore doesn't. Let's do it. I just changed the store ID first, though I don't know logically. Okay, so there is something, a constraint is failing somewhere. So at least that's working. So where is it failing? Insert into table store ID, toy ID, ID in inventory. Oh, what's that? 5, 1, and 34. Oh, the data. Oops. I copied the structure, but not the data. Didn't put data into it. So logically, you have to go in sequence, guys, okay? So it's going to refer a table. It should be available before it. It's not like classes. All I did was I created the store table first. That's all I have done. That's all change I have done. It's just in sequence. So the first table was the tables, TBL toys. The second table was TBL store information. The third table was store inventory because it had a constraint referring to fields. Those fields must already be defined. That's all. And again, the definition of table, you can just kind of put it, you can put it in your comments at the head. Here, when is a table said to be in the second normal form? So that you don't forget it. You can always keep the definition at your, I'm just keeping it. It's not it's just for your information. And we should be okay now. Let's try it again. So sequence is important. There we are. So this is show tables, right? The show tables command just shows the table in the database. This is your table for the store. This is your table for the inventory. Kind of looks odd. Just numbers make no sense, but we'll learn how to make sense out of them. And that's about your toys. These are the structure of the toy table, of the second table, and of the third table. So all three structures, all three data, and the constraints. So now all my three tables are in the second normal form. One more normal form before we can start the choice. Okay, take a break. Take a break, 15 minutes or so. Please come back at 9:45. That's 13 minutes. This is saved and this will go back on Blackboard. So whatever we are doing in class will go back on Blackboard. Okay, so let's take a break here.